Hello, I'm Diego Pedreros. I'm part of the Climate Hazards Group, USGS and FuseNet team. In the next few slides, I'm going to give you a summary of the workshop that we uh, conducted in Colombia, Bogota, Colombia, in March 7th to the 18th. And part of the trainees or part of the participants were members of the IDEAM, IGAC, Minister of Agriculture, Corpoica, CIAT, Finalce, University of del Pacífico y Universidad Nacional, ICOSAGA, and Fede Arroz. This workshop took place with funding from the World Bank. And what I'm going to be telling you will be the way I conduct the training, what are the benefits that these FuseNet products bring to the agencies, in this case, IDEAM and all the other participants. And I'm going to show you some of the applications that the participants, some of the projects that they developed at the end of the workshop, and some other comments. Okay, so let's start with the training activities. What I do is I start going over the data, how we created the data sets, chirps, and all the other data sets. Then we move into the GeoClim, which is one of the tools that allowed the use of the rainfall data sets that we created to do analysis. Then after that, we move to the GeoWRSI, which is the tool that allows the user to calculate the agricultural water balance. Then at the end of the 2 weeks, we come out with a final project where the participants use all they learned in the first 3 blocks and apply to the work that they do in the organizations. Then what I do is the first week we do the data and the GeoClim, and then the second week we do the GeoWRSI and the final project. So this in this case we had about 15 people that were regular, and in total there were like 26 people that came. Some came for the first week and others came for the second week. So having these 2 weeks allowed us to go in detail in the process of developing the how the fuse products were developed. In this case, this is the process of developing chirps. First, we take satellite data, we join it with climatology that we developed in the Climate Hazards Group, and that produces chirp without the S. And then we add the stations, and that's chirps with the S. And chirps has 2 data sets, one that is preliminary that comes every 5 days, and then the final that comes in the middle of the second month. Then any of these 2 products could be modified using the GeoClim, and this is the final step of the process that we did. And so we were able to go in detail on each of the steps. Once we click on these links, it opens up all the different processes. We moved then to the Fuse tools. We went over the GeoClim, which is the tool that allows the analysis of the rainfall and temperature of evapotranspiration. And then we moved to the GeoWRSI, which is the tool that allows the calculation of the agricultural water balance. And then we went through the other tools. These 2 are visualization tools that work on the web, and the GeoCov is the tool that helps on doing forecast. And then this is the coverage of the rainfall data set that we produced. This is chirp for a decade in 1998. Once we covered the overview of the tool, we focus on the GeoClim. The GeoClim allows the user to select either rainfall, temperature, or evapotranspiration, and calculate statistics, calculate trends, calculate SPI. So all these different functions and more. So it was very useful for the participants to be able to calculate these functions on a graded data set instead of the usual that they do on the station by station basis. So then we went to through the products from the GeoClim. This one is one of the products. This is the blending of the stations with chirps. What we do is we adjust chirps with the stations, and then these are the results of the different products. This is the way chirp before we add stations represents the variability of the stations. So this is about 46% in R squared. So this is the data set that has no stations in it. Then we move to this is chirps. This is once we add the stations. The R squared moves up quite a bit. So this is how chirps represent the variability of the stations with then the final product. This is how the IRE, this is the improved rainfall data, the improved rainfall estimate, the process that is done using the GeoClim. So this is the final product. Something that was very interesting was doing the analysis with the experts from the IDEAM and the other organizations to look at the products. For example, this was one of the products from the GeoClim. That this is the average rainfall from 1981 to 2010 for the February-April season. So it was very interesting to see how they looked at this and understood how well it represented the reality of the country. So this is the trend, also looking at how rainfall is what is the trend in rainfall for the last 35 years. Then we move to another example is the SPI, which is a drought index, and this was very useful for them to see it, since they calculated using stations, and in this case, being able to calculate it using raster was going to be very useful for them. After the GeoClim, we moved into the GeoWRSI. The first activity was running the GeoWRSI for a single point. This is a very fun activity that we do, where they learned all the different aspects of the model, all the different outputs, all the inputs, all the different parts, and once they understand this, and we move to the real model, so it's very easy to understand the outputs from the tool, because they already got the whole process down. So when we move to the real model, it's not a problem. So this is the agricultural water balance for average for Colombia. This was a big challenge because the program that we have is set up for Central America and Africa. So this is the first time that we set it up for another country. So it was a lot of work, but it was worth it. It was very useful. They found it to be very, very good. I also added a new tool that I'm testing to see how good, or how people perceive it, and how useful it's going to be. So this is a tool that shows these are all the different rainfall, the different years, the accumulation of rainfall for the different years for a given region, and the black line is the present year. So every time there is a new decade, that we added to this black line. So the black line is growing, and so I wanted to see how the participants would take this tool, and it was very useful. They found not only useful for monitoring, but also for prediction to see how well the season, what is the possibility of the season ending below or above average. So they found it to very useful. So we're going to be recommending this tool to be part of the GeoClim in the next version. Right now, it's just it's available in other tools, but not in the GeoClim. So the participant could select a given polygon and then calculate all the totals for the different years for that polygon and plot this graph. Then the next step of the tool is that it changes all the years to the point of observation with the data for the present year, and then from then on is the data for all the other years. And this allows us to see better the probability of going below or above the average at the end of the season. So they found it very useful, and I think it's going to be very good to add it to the new version of the GeoClim. So then after we look at this tool, we move to the different benefits that these products and tools would give to the IDEAM and to the country as a whole. So the first thing that we heard from IDEAM was that going from stations to raster, going from the points, doing the analysis at the point level, instead doing it now at the raster level would be a great benefit. Also, having a high resolution product, the rainfall product that we produced is 5 kilometers per pixel, would be very useful to have such a high resolution. Also, calculating the water balance at a regional level instead of the points was another great benefit that they found, because they do the agricultural water balance at the point level as is done by the FAO, and they could produce better service to the users of IDEAM's data. So here we're going to give some examples of the different projects that the participants produced at the end of the workshop. So the question was to use for the work that they do, to use the data and the tools that we just had learned in the days before. So one of the participants from IDEAM showed that she produces forecast. So this is the number of points that she uses in a regular forecast, 598 stations, and this will be the number of points that she would use if using the data set that we coming from the GeoClim. So it would be 16,000 points. So it would be a huge difference. This would cover the whole country, while this covered just certain points. Juan Gomez and Hugo Saavedra compared 2 years of the WRSI. This is the agricultural water balance, and they focused on how this tool could be used to monitor agriculture irrigated areas. So they, based on their expertise and understanding how the model works, they made some suggestions on how we could monitor irrigated areas using this tool. The next project was done by people from EcoSaga, a couple of participants. And what they do is they have a project in southern Colombia in El Cauca, and they have their own stations. So what they did is they used the GeoClim, used chirps, and used their own stations to produce a higher resolution data set that would create more variability, that would show more variability for just the region where they work. So this was a very good exercise, because chirps is 5 kilometer resolution, but they produced a 1 kilometer resolution data set. So the next project was an analysis of the conditions from last year of maize. And this project took all the different outputs from the WRSI model and applied and compared it with the conditions that happened last year during the 2015 growing season. So what she did was this is the rainfall by decades, 10 days totals, and this is the result for the different decades of the WRSI model. So to this point, to decade 14, is this right here, and this is decade 14 of rainfall. So what this is showing is that the WRSI is showing that there was enough rainfall to support the growing of maize, and this was on average. This is the light green color right here. So, but the rainfall started decreasing in the next few decades. So by decade 18, by decade 16 right here, we have it right here. There was less and less rainfall, so the WRSI product was showing mediocre. And then by decade 17 and 18, there was no rainfall, so the WRSI is showing poor. So the rest of the decades, there's still very little rainfall. So even though there was some rainfall in decade 20, it was not enough to recover. The damage was already happened, so had already happened. So there was no way to recover. So at the end of the season, there was a really poor WRSI values for this region, and that's what happened in reality last year in 2015. So this was a very good exercise to validate the product, and even though it was the first time that we ran it, we got it to represent what happened last year very well. So the next project was from Mary from IDEAM, and she compared the satellite data that IDEAM produces right here on the left with the output from the geoclim, from blending the stations with chirps. And these two maps are in the same scale. So we see that what she found was that the satellite data from IDEAM does not include high rainfall values that come from that come out in the output from the geoclim. So this was also a very important finding, and comparing the data from IDEAM with the product from the geoclim. The next exercise was from Olga and Ruth. What they did is they compare the interpolation process that they do at IDEAM at the present moment with the products from the FuseNet. So these are the stations. There are a few stations along this border right here, and there's a station right at the tip of the Amazon, and everything is interpolated between those points, between these points right here and this point right there. While the products from FuseNet have some values from the satellite. So having values from the satellite really help, while this process only has interpolated values. So there is no support in the. So these are some of the examples from the final projects, and then following is going to be some evaluation that I did of the workshop. So I asked the question how overall how satisfied they were with the workshop, and they were very satisfied. The next question was how the content of the workshop met their needs, and some worked extremely well. Then how the data sets, what was the quality, that was between high quality and very high, and the applicability of the tools was also very well taken. And the next was how the tools, the installation of the tools. Yeah, we know there were many problems, but we already fixed some of them, and now we have a new version of the tools. Then we move to the evaluation of the instructor. This is the knowledge of the instructor. Then after the knowledge, how well the instructor communicated the, the material. So the next steps, the first thing that we're doing is redoing the training materials in a different format. And now we're putting together into a single platform all the different tools that we have. So finally, we need to start to help IDEAM implement all these tools and processes into their system, and that's going to be the main thing that we need to do next. And then we have another training in about 6 months or so, and we need to start talking about it, and that will be in the near future.